Assalamualaikum and greetings to all. We are from group 21 and today we're gonna present our group project in project 2 of KNJ2332 of engineering programming. So my name is Zamrin bin Karman. So I'm gonna talk about the engineering problem. So what is the problem? Basically, our problem is related to the application of Newton's cooling law. In this situation, a can of Coca-Cola at normal temperature of 27 degrees Celsius is placed into a refrigerator where the ambient temperature is 12 degrees Celsius. Based on Newton's cooling law, we could actually determine how the temperature changes over a period of time in that refrigerator. So standard way of approaching this type of problem is to subdivide the time interval into a number of small step size for each duration. From that, we could analyze the pattern change based on the equation. To make the outcome more effective, we should apply some conditions where it becomes as variable in this problem. Firstly, we should record the temperature for interval times of 10 minutes over a total period of 100 minutes. Secondly, the temperature of the can must fulfill conditions where its initial temperature is around 13 to 28 degrees Celsius. If not within this range, the equation is not applicable to use to compute the temperature. And lastly, we should plot graph temperature against time. So these are the equations used to solve the problem. We could observe the temperature change for each 10 minutes based on the recorded initial temperature, the coefficient, the conduction coefficient, the ambient temperature, and the time interval. We know the conduction coefficient is 0.06, the ambient temperature is 12 degrees Celsius, the time interval is 10 minutes, and record the initial temperature. So from this all information and condition, we could build a MATLAB program to solve this engineering maths problem. That's all from me.
Okay, we move to the next part, which is the program design. Before that, I introduce myself. My name is Muhammad Lokman and my metric number is 64888. Okay, I will show and introduce our project program design. Basically, program design must have three things, which are algorithm, pseudocode, and flowchart. So we move to the first one, which is the algorithm one. Okay, in algorithm, we do a step-by-step process from the beginning of the program until stop the program. For our group project, this is our algorithm, which is start. The first step is start. Second is input any value of initial temperature again, which we refer to the T1. So if the T1 is less than or equal to 12 degrees Celsius, it will display equation of valid temperature is same or below than refrigerator and stop program. Step number 4, if the temperature of the can is more than 28 degrees Celsius, and it will display equation is not valid, temperature is greater than refrigerator, and not stop program. Otherwise, from the previous two statement, it will display equation is applicable and then it will execute. Number 6, get a value of conduction coefficient K equal to 0.06, refrigerator temperature F equal to 12 degrees Celsius, the time interval marked as delta T equal to 10 minutes in total of 100 minutes. 7, compute the temperature based on the equation that is set in this figure. 8, it calculate the temperature for for the iteration of 1 to 100. 9. It will display the result of the temperature for every 10 minutes. Last but not least, it will upload a graph of temperature against times, and the program will stop after that. Okay, next we move to the flowchart. In this flowchart, I don't want to give more explanation about the command, but we're more focusing on the shape of each input. So the first one is the oval shape, is equal to the start or stop command. Second one is the trapezoid shape, which refer to the we can insert input or output command. The third one is the rectangular shape, which refer to a processing command. Yes. The fourth shape is the diamond shape, which is refer to a decision command, which normally which refer to yes or no statement. And lastly is the direction of flow, is we note as arrow. So the third program design is pseudocode. Among the three program design, pseudocode is the most simple than the other previous two. The pseudocode is almost similar to the algorithm one, but the main difference is pseudocode only key in for the keywords of the command and not the full sentence, like in algorithm. So this is our pseudocode. They have 14 steps, and that's it for the program design. Thank you.
So, hello, I'm Muhammad Fadil bin Kamaluddin. We'll continue the next part of this video, which is explain the code that we have been used in our program. So we proceed. For the first, we use the input function, which we can put any value that we want. Next, we also use the logical function or the conditional statement, which is to determine or identify which is the true statement. Then in this program we also use the relational operator, which is for this statement, if the temperature of the can is less than or equal to 12, it will display the equation is not valid. Next, we also set the conduction coefficient and the temperature of the refrigerator value, which is 0.06 and 12 respectively. Next, we also set the array of the time variable 0 until 100. In this array, we don't put any specific value of the increment. We show it will automatically increase this value by 1. Then we also set the matrix of the temperature with the row of 1 and column of 101. In this program, we also use the for loop function with the value of the index matrix from 1 to 100. After this value of index matrix has been run off, it will proceed to the next, which is the display of the result. The result have been shown in this program is the time variable from 1 to 101 with increment of 10. Same goes to the temperature of the can. It means the value shown is in the interval of 10 minutes. Then the plot of the graph will be shown with the graph of temperature against the time interval. So that's all. Thank you.
Okay, so for my part, I will show you how the code works in command window. So in this case, our condition is the code is applicable when the temperature is between 12 and 28. So first I'm gonna show you when the temperature is below the limit. For example, the temperature is at 10 degree. So it shows equation is not valid. Temperature is same or below than refrigerator. So we can run the code because the temperature is below than the limit. So another example is I will show you when the temperature is over the limit, which is 30. So it also show equation is not valid. Temperature is same or below than refrigerator. Okay, so I'm gonna show you how the code run when the temperature is between the limit. For example, 25 degree. So this is how the code running. First, it will show you the table. This is the time, and this is the temperature change. And this is the graph, the curve being plotted between temperature against time. So when the temperature is 25, basically here, so it will change over time, it will reduce over time until temperature is 12. I'll show you another example. Let's say the temperature is 27. So here, it also shows the table and the graph. So I show you last example. Let's say 20. So it show you also the graph, the table, and the graph when the initial temperature is 20. Here, 20. If it goes down against time. So that's all from me. Thank you.